Okay, so this is day 30 of doing Leetcode daily until I get a job. So we will just continue with what where we left yesterday. And this was where we left yesterday. We were just trying simple division, but that wasn't working at all, as you can see. So let's go to the basics and how do we divide the things? Like we did the multiplication quotient similarly. Okay, and so for that, let's firstly handle the cases, edge cases basically, where int min or int max are involved. Okay, int max is fine, but let's talk about int min. Okay, so if let's take something small for them, like dvds maybe. Okay, if divide dividend is int min and divisor is -1, what do we have in this case? So if dividend is int min, this is a -1, divisor is also negative, we will just return int min. Perfect. Similarly, if dividend is int min again and divisor is 1, we'll just return int min. Perfect. Now let's take the absolute values basically, because for the science we will deal with it later. For initial purposes, just take, because see, the int max will not be even possible here, because why do we took only int min corner cases is because of this condition, that this range. Okay, so now let's take the uh, absolute values of them. So we can take long absolute dividend as this and absolute divisor as this. Fine. Now how do we divide the things? Let's store our result in our answer variable, and how long do we divide a number with another number? Let's just say we have one number as 52, another number as 7, or let's say 5. How long we will divide it with it? Up to when this number is less than 5 or equal to 5. Yeah, correct. So firstly we'll do what? 5 to 1 and 5 10. When it, and after dividing it by 5, with basically multiplying it with 10 minusing it. So how does this divide thing work is, see, 52 by 5 basically results in 10. If we take the integers only, 10 point something it should be. So how does this thing work is that if we multiply this 5 with this 10, it will result in what? 52, and it will be 50. So it will, the result will result in 52 minus 50 as something of 2, which is obviously less or equal to 5. Correct? So how will the thing work is, initially the number is something, let's say initially the number is dv. Okay, initially we will try to multiply it by 1 only. 5 1s are 5, we'll start from there. 5 ones to find 5 here, right? So and then we will keep multiplying it, and so while let's take another variable, let's say x as this, because we want to store the original one also, we don't want to change it. So what will happen is, while this x is less or equal to sorry, our dividend, yeah, dividend. Okay, this is divisor, this is divisor basically. This is divisor for with which we are dividing the dividend. Okay, so the dividend will be equal to this minus of x. Okay, up to then we will go, and what we will do in this while loop is this x will be doubled, fine, and this temp will also be doubled. We'll see with that an example obviously, and then after this loop ends we will add temp to our answer. See, we can see what's happening with temp here, that for initially temp is 1, then temp goes to 1 plus 1 2, then 2 plus 2 4, and 4 plus 4 8. So it's going like this. Okay, and this dividend, minus equal to will be x, that x of it's done, rest of it we have to do, and this all is in the while loop. And what is the condition for that while loop is this one, that while the dividend is less or equal to divisor is less or equal to dividend. So let's just say we are dividing 5 with 52. So until 5 is less or 52 is greater or equal to 5, we will go forward. Okay, initially we will do what, let's just do this thing. Initially x will be 5 and temp will be 1. So in the first iteration x is 5, temp is 1. Now we will run this while loop, that while 5 is less than 5 is less or equal to basically our dividend 52 minus of 5 means 47. We will do what, x plus is equal to x, so 5 will go to this, like, okay, 5 will become 10 and multiplied by what, 1 will become 2, temp will become double of it, so 5 2s are 10. This will be the thing. Okay, now this thing, this is x here. Okay, this becomes 10 now, and this becomes 52 minus 10. That out of 52 10 is done. When it is done, when 5 is multiplied by 2, then again 10 will be multiplied by 10 will be added to 10, so this 10 will become 20, and this 2 will become 4, and it's the same thing, that 5 into 4 is 20, and this will become 20, and this will become also 20. So out of this 32 remaining, now 20 will become 40, so now 20 will become 40 and 4 will become 8. Yeah, we know about this. So what will be, this is 5 8s are 40 and 12 is remaining now. Okay, 40 is it less or equal to, but now see, at this point it becomes out of bounds, correct, because this thing, now 5a into 8 40, at this point it breaks up, it breaks down, correct, because when it was 20 it was fine, when it was 20 it will enter the loop. Why? Because 20 is less or equal to 52 minus 20, 52 minus 20, but when it becomes 40 it will break out of this loop. So now x has become 40, temp has become 8, because 5 into 8 is 40. We know with what we have multiplied it. Okay, so our answer will add this temp to it, that answer will be now 8, fine, and our dividend will become now 52 minus what have we got, 40 have we got, so 12. Now 12 is remaining, and 12 is the greater or equal to 5. Yes, it is. So again the while loop will run, the outer while loop. Inner while loop, what will we have, x will be again to 5 and temp will be to 1, The while loop will be, condition will be while mul means the x is 5 is less or equal to what? 5 is less or equal to this dividend minus means 12 minus 5. Up to then we will go. So first time it will go because 5 is less or equal to 7. So one time it will go and it will become 10. So x will become 10 now. Okay. Temp will become 2 now. So answer will get this 2 added up to itself. So answer will be 10 now. And dividend will become 12 minus 10, 2 now. But now 2 is not greater or equal to 5. So the while loop will be ending here. No more iterations. And we have got the answer here. Because uh, whatever it's less than that, we don't have to care about the decimals of the number. We just have to find the floor value. And this is what we have. Fine, so that's how it's gonna work. So it's become simple now. So while the dividend uh, dividend is less or equal to divisor, we will go forward. We will take a variable int x, which will be equal to our divisor, which is ads initially, and we will take a temp as 1. Fine, so while we will go with the while loop inside up to when x is less or equal to our dividend. Dividend is what? ADV. ADV minus of this x itself. So basically 2x is less than this, and that can be kind of interpreted from this. So yeah, up to when this is happening, we will be doing what? X will be double of itself, and okay, not a, it will be x plus is equal to x, and temp will also gets doubled. Perfect. Temp has got doubled, x has got doubled. Now we will add this temp to our answer, and we will minus something from the dividend, and which is our value of x. And here now we just need to talk about signs now, that if dividend is also less than 0 and divisor is also less than 0, both are negative or both are positive, then we have to return rest, else minus rest. So else this condition, or either this condition or this condition, so either this or both are greater than 0, we will just return the answer we have, else we will return minus of answer. Perfect. Okay, so we got a wrong answer here somehow. Our output is coming out to be 3, but it should not be. Then we are being mistaken somewhere here. So while dividend is less than okay, no, not dividend is not less than, dividend is greater than. Okay, fine. This one, yeah, that should be fine now. Okay, if we have a int min and we have -1, there should be int min itself. Okay, it should be into max. Fine, I got it. Oh wait, I mistakenly clicked that. Yeah. Okay, so it will be into max. Fine. So it should be fine now. Perfect, it's working fine. Let's submit this. And okay. Okay. Okay, we have to have a end long end, we can say. If this will work, use this test case and run it now. Okay, man, enough of it. Oh, enough. If we remove this long, is that fine now? Where is this problem there? Long. I guess long must not do this. Long int must work, admit. Don't you think so? Okay, long int will work here, but long int will not work here. It has to be the same, right? Okay. Can be represented in type int. Negation of this cannot be represented in type int. Cast to some unsigned type, negate this value to itself. And we did that. This should work, I guess. This negation thing. Yeah, this negation thing should work because we are finding the absolute value and we are taking the long int. But fine. Yeah. So we cannot use the long int here. That one thing is for sure. We cannot take the long int here. I mean the concept is correct, but these variables are how to handle these variables. I'm not sure. If maybe this absolute thing doesn't work with them, so what if we do this? Perfect, it works now. Yeah, so this is done with 100%. Yeah, that's good. So let's now move to the next question, which is substring with the concatenation of words. And have we done it? No, we haven't. So let's start with this. So we are given with a string as an array of words. All the strings of the words are of same length, and concatenated string is a string that exactly contains all the string of any permutation words concatenated. So if words are A B C D E F, then A B, then they are any permutation of all the letters connected is called a concatenated string out of this words array. And return an array on the starting indices of the concatenation. Fine. So if words are this, Then we have to find the indices where there is a string either foo bar or bar foo. So bar foo is here at the 0 and foo bar is here at index 9. So these two index will return. So fine. Um, Obviously, firstly we will store these element of words in map. So let's just take a unordered map for that purpose. Unordered map for string print. Perfect. MP. And for uh, auto I in words, we can write MP of I plus plus. Yeah, fine. And we are also given this that all the strings are of the words are of same length. So they are of same length. So we know that the substring which we need to match, we know that. Okay, so let's just take the word size also. So int word size will be equal to what? Words 0 dot size. Fine. Now we will start from the very first index. So let's take an index where we are starting iterating from. So while uh, how many words are there, let's take that also. Int n is words dot size. So while the I plus n times of word size, yeah, that's correct, I plus n times of word size is less or equal to 0, less or equal to actually s dot size. Fine. So if this is the case, we will check that if a substring starting from index I with the size, see if let's call a function which will check that the substring of s starting from I with size n times of word size, the size of whole of words, is, can we make the whole this string out of this map where size of each word is word size. If this is true, then we'll take an answer array, we will push back the index into it, and okay, if it doesn't, we will just go for the next index. Oh, but it will be incrementing it obviously no matter what. So I plus plus will always be here. So yeah, I guess that should be the thing. And yeah, let's take answer array. So vector and answer. Check now. We need to write this. So it will be a boolean value, and we will check for a string we are getting, unordered map we are getting, unordered map we are getting, and size of the word we are getting. So int word size. So for this we will check. How will we check is simple, quite. Yeah, that for we will go into this whole string from index 0 to si as word size I plus plus, and we will take the initial substring which will be, let's say, str, and it will be s dot substring starting from I of word size. If we will take word by word, so we will take a word size that this word is here or not. So first three element of it, bar, because three is the word size here. Okay, so first three element of it starting from the first index, and we will see if this is in the map. Okay, we will check that. So how will we check it? This mp dot find the str. Okay, it's dot type. Just find str not equal to mp dot and if we find it out, then okay, then we will just decrement the mp of str. Okay, and after decrementing, if it becomes -1, because let's see, if we have a substring here, okay, and we have it and we found it, we decrement its frequency, now it becomes 0. Its frequency is 0 but it's still here. Okay, or we can do one thing, we can just simply do this. If mp of str is greater or equal to 1, then mp of str minus minus, and if we don't find it, if it's not greater or equal to 1, it's 0 or something less than that, then we will just return false. And if we do all this thing and still get out of it, so we will return true. So it was kind of simple if we go with the flow. So if we don't have to do this. So it's printing nothing here. So the string is coming here. Let's see if it's coming here. See out. The string is coming here or not. Handle. Okay, the string is coming here. Fine. Bar flow is coming here. Now, see out the str here, and means the string here, and let's just check if mp of str is something for this. Mp of str. Fine. So if we do this, then farbro is here, bar is here, but okay, got it. So it is checking for bar, then it's checking for arf, but it should check for foo. So the increment should be of n, not 1. Yeah, I guess this was the error. I plus is equal to not n, basically it should be a word size. It should jump word size number of steps each time. So yeah, this should work. So if we run this now, okay, again it's doing this 9. Fine, let's just go again and run this. So for 0 it's working fine. Fine, for 0 it's working fine. Okay. So then it's checking for, so when it's again coming to foo bar, foo is coming 0. Okay, it's coming 0, so it should not be referenced. Okay, it should not be referenced from there. It should be coming again new and new. Okay, now I got it. See, the difference here is when we reference it by its address, okay, then we reference the original one, means the deep copy of it, and we make any changes to it, the changes are made to the original map. And we have a parameter like this which is referenced by value. It's a shallow copy, means we make a copy out of it, and if we do make any changes to it, the changes will be in that copy, and every time we call this function, the parameter will be a new one. So the original world remains safe, so that we can send that original, the copy of that original one, every time we call the function. So that's the difference between these two things. That's why you can see that sometimes we use and sometimes we do not. So, okay, time limit exceeded for the last test case. Yeah, we got something here. Just a second. It's 30 minutes and we haven't even done two questions. Well, that's a pity. Huh? No. Okay, so Mhm. Let's try to do this. Time limit exceeded. Why is the time limit exceeded? I is less than s dot size sign. See, maybe something here, because time limit only exceeds when a loop is not closing up. When there's a problem with the loop, and for we are incrementing the I, but rest of the questions are done. So why is it? Rest of the test cases are done. So how it can be doing this is as when okay, okay, I guess. See, the string is this, a long one, fine, and the words are this. So maybe the word length is one here. So this loop is running for so long. And inside that also, this is the problem here, I guess. So instead of that, yeah, I guess this is a thing where it's failing. So let's try this. I'm not sure if this will work, or if this will work, why will it work? I'm just not sure at all. But let's just try this. At imperial finance is not equal to imperial and if this is the case, and if minus minus of mp of str, let me change the color of it. Yeah, str is equal to -1, then return false. The process which we wanted to do earlier but didn't. And if we run it now and we use this test case, well, I told you guys, I don't know why this works, but this somehow works for this test case. And there must be some complexity issues with that thing. We are checking the frequency directly and decrementing it one by one, but it doesn't happen with this. And I don't like, there's not a major difference. Might be some conceptual difference at the base level, but not from my level at least. So I don't know what the issue is here. I will try to check the issue and will address in the tomorrow's video, but uh, it works somehow, and I don't know why that doesn't work and this work. This for the one test case, okay. 181 out of 82 is already passed, so that's fine. And yeah, we got it. So let's go to the next problem now, which is next permutation. See, next permutation is simple thing that we have a number here 123. What could be the next permutation of 123 is with only these numbers 1, 2 and 3. What is the just next bigger number than 123? 132 it could be, right? Because 213 is not just bigger, 132 is the next. So we have to go for the next permutation, and there is a inbuilt function for next permutation in STL of C++, but we are not going to use that. And let's try to implement the conceptual, let's have the conceptual clarity of the next permutation, that how that inbuilt function even work. Okay, so let's take an example. If we take 1, 3, 2, 4, what will be the next permutation? Think directly of it. It will be what? 1, 3, 4, 2, correct? And what will be the thing about 1, 5, 1, 5, 2, 4, 3? What could be the answer for this one? Try thinking. I guess you did it. So it will be 1, 5, 3, 1, 5 will be same, and 2, 4, 3 से बड़ा क्या हो सकता है? 2, 3, 4 तो होगा नहीं भाई, 3, 2, 4 होगा. So 3, 2, 4. तो हम इन दो एग्जाम्पल से पूरा समझ सकते हैं कि ये हो कैसे रहा है. तो पहले इस वाले को देखते हैं. So if you look at this 1, 3, 4, 2, so we can see that for 1, 3, 4, 2, we have done what basically, apart from this we have done what. यहाँ से यहाँ जाने के लिए हमने किया क्या है यहाँ पे, ठीक है, हमने 2 और 4 की पोजीशन चेंज कर दी, ठीक है. बट हाउ डू वी फाइंड द पोजीशंस विच वी नीड टू स्वैप, और द ऑपरेशंस विच वी नीड टू परफॉर्म. तो देखो हम स्टार्ट करेंगे यहाँ से, विल स्टार्ट फ्रॉम द हियर, ओके. और यहाँ से शुरू करेंगे कि we have to find the element where the I plus 1th element is greater than the ith element, means the current element is smaller than the next element. So 4 के next तो कुछ है ही नहीं, तो हम यहाँ को तो हटा ही देंगे. यहाँ से शुरू करेंगे. The element which is larger than 2, if it is 4, the next to 4, next to 2, okay, is 4 greater than 2? Yes it is. So we will break out of it, the loop here. Now one more case comes here is, what if the number was like 3, 2, 1? Means there is no number which is smaller than its next number. पूरा डिसेंडिंग ऑर्डर में है ना ये तो इसका नेक्स्ट परम्यूटेशन क्या होगा, मतलब ये अपने कैरेक्टर्स की फॉर इट्स कैरेक्टर्स it is the largest number, so next will be the smallest one. We will again go to the start, so we will just reverse it. If this I becomes -1, means we go and go and go and we reach here, left of 3 means -1. We'll just reverse the number and return. Else if we find a I, let's say now we find a I here 2, that for this I plus 1 is greater than this. So now we will start from the end again with another variable, let's say j, and we will find the j, we will find the first j from right hand side which is greater than 2. We find this only, 4 is greater than 2 and it's to the right of it. Okay, so we will just swap those nums I and nums j. So 1, 3, 4, 2 will be it, and this is our answer. But will this thing work in this case also? Let's try to find out. So if we take 1, 5, 2, 3, 4, fine, we will start from here. 243 basically, 243 it is. Okay, man. 15243. Okay, we will start from here. Is 4 less than 3? No. Is 2 less than 4? Yeah. I is this. So if I is this, we'll break out of it. And now we'll start from the end with a variable j, that the first j which is greater than I. So is 3 greater than 2? Yes, we here it is greater than 2. So this will be the j. We will swap them I and j. So it will become 15342. But is this our answer? No, this is not our answer. Our answer is 324, not 342. So what we need to do is, this was the I, right? This was ith position. So whatever it is ahead of I, means I plus 1 to the end, we will reverse it. And this will give us the answer. So 15324 will be our answer. And this is the next permutation. And this is where all cases are covered in these two examples. And one is this example where it's purely descending order. So yeah, we can start doing the question now, and you can see here how we're doing this. That, yeah, so let's take the size of it firstly. Fine. And let's start from the last second element, because for the last element there is no next element, and next j also. So while I is greater than 0, we will run this loop, and if nums I is less than nums I plus 1, I plus 1 से छोटा हो जाएगा, at this moment we need to break, else we will just go with I minus minus. So we have to make this check that if I is equal to minus 1, means the array is descending order, then we will just reverse the existing nums, and we have to change in place using constant extra memory. So we have to change this array only. So we will be reversing the nums dot begin to nums dot end. Fine. And if this is not the case, we have some I, then we will start from the end. We have already j is equal to n minus 1 to j greater or equal to 0, and j minus minus. If nums j, the first j which is greater than I, we have to take it. We will swap the nums j with nums I. We'll swap them, and we will just break. After swapping, we also have to do one thing, that we need to reverse the which elements, nums dot begin plus whatever next to I, means I plus 1 to nums dot end. We need to reverse it, and once we do this, we have our answer. So like, this is how the next permutation even in the inbuilt function, this is how it works. So we should know the underlying architecture of how this is working, what's the algorithm of it. So this is the process. Okay, what's it? What's this? Nums dot begin. Okay, plus I plus 1. So fine, I guess this should work. Yes, it is. And yeah, perfect. Let's go to the next question. And this is the longest valid parenthesis, so this will be the second hard of the day if we do this. And the time is 44 minutes, so let's try to do this in 16 minutes. And I don't think this question is that much hard, because just by looking at it, we have to return the longest valid parenthesis, and that's a DP question just by looking at it. And why this is so is because we can have solutions for a specific length up to I, and we can store it in DPI, and for the I plus 1 we can interpret the answer from the previous character plus the answer we have got up to previous length. So let's firstly take, like, if n is See, if n is 1, then there will be only one character and that could never be valid, right? So if let's take int and s dot size, s dot size, fine. And after that, if n is equal to 1, basically it's less or equal to 1. If it's even nothing here, we will return 0. Give it to the number. हाँ, अरे भूल गया मैं तो अभी. हाँ कहूँ से मैं कल ही कहूँगा, कल तो लेके ही रहूँगा. So if it is less than 0, less or equal to 1 actually. Fine. I do this sometimes. Okay, so okay, let's do what is, let's take a current, or we need to have a current or not. Let's take it for now. Take it as 0, obviously 0, and our vector int, it will store, okay, and 0. Now let's start, and we will compare with our, see in this question the thing is simple, that whenever we get an open one, we don't do anything because this is obviously invalid. But when we get a closed one, we need to check if the previous one was open. If it was, then we will add whatever answer was up to here plus 2, means dp, this is I minus 1, this is I minus 2, so dp I minus 1, I minus 2 plus 2. But it could be like this also, and we are here. For this our answer is added, but what for this? And what if before those 4 brackets there was also these 2 brackets, so this was the string. What's in this case? Okay, so let's write the first case for now, that we are starting from 1, I is less than or equal to n, I plus plus, fine. Not equal to n, obviously not equal to n, why we are doing this. So if si is what, closing one we have to consider, because opening we do not have to, it will be 0 for that. If this is 0, and if si minus 1 means the previous string or the previous character was the opening one, then dpi will be equal to dp I minus 2 plus 2. Perfect. I guess this is fine. Okay, perfect. Now after this, if this is not happening, if the previous string is not opening one, and it's like, see, if previous one is closed, so there might be cases in here now. Okay, and it will be, but what if in this also, what if it's, if I is equal to 1, then dpi minus 2 is nothing, it's minus 1, so it will be out of bounds. So I must be greater than or equal to 2 for this dpi minus 2 to exist. So for this we can write a condition here that I is greater or equal to 2 agar hai, then this, and if it is not, then just simply 2. Fine. Now the else case comes here, and these kind of strings comes here. Okay, so for this what will be the answer array for this? 0. At this length it will be 2, again at this length it will be 0, at this length it will be again 0. For this character it will be 2. Now what for this character? See, firstly, this character checks the previous character. It's not matching, we will skip it. But if this is not matching, again, if this is closing and its previous one is opening, means if this answer is something, if this dpi minus 1 is greater than 1, which means that this is a valid string, because it will be greater than 1 obviously when it is a matching with something, otherwise it will be have been 0. And if it is matching with something, we will check this string, and if this string is opening, then we got it, we have one more answer, and whatever answer is behind of that, we will just add it. Fine. So what we're gonna do is, in the else if, the we have to check if long the dpi minus 1 is something, does it have an answer? Okay, does it have an answer? So it should be, yeah, it should be this: I minus dpi minus 1 is greater or equal to 1. So if I minus dpi minus 1, dpi minus 1, what does dpi minus 1 suggests? Dpi minus 1 suggests answer for this element, and the index minus answer for this element means the longest string up to there. If it is greater than 1 or equal to 1, means we have something here which is matching with the previous string, means the previous string is valid one. We know that after of this condition is, if this condition is true. Okay, and if this valid string, then we can check for this, otherwise we will not be checking for this obviously, right? Because if it was this, why will we checking? Or if it was this, why will we checking this one? We won't be, right? So if this is the case, and s, and we have to now check the previous string, skipping those two strings and the third one. Okay, and how do we do that? Let's firstly replace this here. Okay, so it will be I minus dpi minus 1, whatever the valid case of string was there, and the previous one of that. So uh, minus 1 of that, minus 1 of that. If that is equal to opening one, then we have answer. Inside that, we will also have a condition. So after that, the dpi will be dpi minus 1, whatever the answer was up to here, plus 2 for the current valid string. Okay, plus whatever we have behind this answer we also need to add, right? So we'll be also needing to add this answer, and what it will be is, if firstly we need to check if this was valid also, if there was a string existing behind that also. So if I minus dp I minus 2, sorry, I minus 1 and minus 2, it existing is greater than 0. Okay, is greater than 0. If it is, then we will add dpi minus 1 minus 2. Fine, dpi minus 2, and we add that. Else if it is not, we will just add 0 to it, and yeah, that will be fine, and we will just return dp n minus 1. I think this should work. Let's just see here. Okay, 2 2 4. Okay, we need to return the maximum out of it, not the last. So we will just return the max element out of this dp vector. So it will be like this. It will be like this. Perfect. So this is full. Let's try to submit it. And yeah, it's 100%. Perfect. That's too good. Fine, we are good with this now. So this is the end of our day, I guess. Which day is it? It is day 30. So this is the end of day 30, and we have completed successfully 1 month, but haven't got a job. But yeah, I'm trying for it. And not just the DS, I'm doing a lot of other stuff which is important for that also, but no luck as of now. So we'll just keep trying until we are done, and we are not going to stop before that. And that's it for day 30. Let's meet on day 31 now.